Hi everyone, today we are looking at the LED matrix module based on the MAX7219 chip. First, let's understand how it actually works. Essentially, this matrix consists of 64 individual LEDs, each of which can be controlled. If we connected them directly, we would need 64 pins, but if you detach the matrix from the board, you see only 16 pins. How is this possible? The secret is in their connection. Instead of connecting each LED separately, we divide this matrix into rows and columns. This way, by applying a minus to a column and a plus to a row, we can light up any LED on the matrix. But there is a nuance. We can only light up 8 LEDs at the same time. However, if we light up only one row at a time and change it 1,000 times per second, the human eye will no longer see this flickering, and it looks as if the whole image is glowing at once. This effect is called POV, or persistence of vision. Fortunately, the MAX7219 module does all of this itself. We only need to tell it which LEDs should be on. This module has 5 pins. VCC is the power plus, where voltage is applied, usually 5 volts, for the module to work. GND is the minus, or ground, which completes the circuit. DIN, or data in, is the data input, through which the microcontroller transfers info about which specific LEDs should light up. CS, or chip select, is the selection pin that tells the module that the information is being sent specifically to it. CLK, or clock, is the clock signal pin that sets the rhythm of data transfer so the module knows when to read the next bit from the DIN line. Now let's move on to connecting this module to an Arduino. First, connect the VCC pin to the 5-volt pin on the Arduino. Then connect GND of the module to GND. Next, connect the DIN pin to D11, which is the standard MOSI pin. Then we have CS, which we can connect to any other digital pin, for example, D10. And finally, connect CLK to pin D13, which is the standard SCK pin. Now that the connection is finished, we can move to the software part. Before writing the code, we need to download the necessary libraries. First, download the Adafruit GFX library. Go to the left side of the Arduino IDE and click on the Library Manager tab. Search for the library name and click Download. Also, we need to download another library from GitHub. Follow the link in the description, click the green code button, and then download zip. Now go back to the Arduino IDE, go to Sketch, then Include Library, and click Add Zip Library. Choose your file and click Open. To begin our project, we include 3 essential libraries: SPI for communication, Adafruit GFX for the graphics engine, and Max72xxPanel to manage the hardware. We then initialize our matrix object by specifying the CS pin along with the number of horizontal and vertical modules in our setup. Inside the setup function, we prepare the hardware. First, we use matrix set intensity to control the light level. This can be set within a range from 0 to 15. Next, we use a loop with matrix set rotation to programmatically rotate the image on each segment by 90, 180, or 270 degrees so that our text is oriented correctly. Now let's look at the loop function. This part of the code is for demonstration, showing the most popular graphic commands. We start with matrix fill screen. Using the parameter low clears the entire display, while high lights up all 256 diodes simultaneously. To target specific points, we use matrix draw pixel, where we indicate the x-coordinate, then the y-coordinate, and finally the color state. On our matrix, the horizontal range goes from 0 to 31, and the vertical range is from 0 to 7. For geometry, we have matrix draw line, where we indicate the x and y coordinates for the first point, and then for the second point. To create a frame, we use matrix draw rect, where we indicate the x and y for the top left corner, and then we specify the width and the height in pixels. For curved shapes, we call matrix draw circle, where we indicate the x and y coordinates for the center point and the radius. The function with the most parameters is matrix draw triangle, where we indicate the x and y coordinates for the first angle, then the second, and finally the third. Whenever we want a solid shape instead of an outline, we simply replace the draw prefix with fill, such as matrix fill rect or matrix fill circle. To display information, first we use matrix set cursor to set the anchor point, and then the matrix print command allows us to send strings, integers, or sensor data to the display buffer. Finally, we have the most critical command, matrix write. This pushes all the data from the buffer to the MAX7219 controllers. It's important to note that you need to specify this for all the functions, otherwise no changes will actually appear on our matrix. Now upload the sketch to the Arduino and you're done. Now you can see how all these functions look in reality. I hope I helped you. As always, I'll leave links to the code, libraries, and the wiring diagram in the description. Thanks for watching, and see you in the next video.